This video is going to go over question 6 in 2016. Traditionally, the last question on an AAP test can be just miserable, and you kind of look at it and then decide to go back to other ones rather than do too much on it. This was the exception. I actually thought question 6 in this entire test was possibly the one of the easiest, mainly because it was very focused on generic derivatives and integrals that we do a lot, and you did not need to have a lot of extra explanation and justification. The math kind of took care of itself. So we're going to go through the rubric from the AP, and then we're going to go through and I'm going to show you mine, again, just in case you write yours differently and you want to see how I wrote mine. So this question gives a table of information that represents F, F prime, G, and G prime. And then part A and part B are both generic derivative questions. Part A also has a tangent line piece. And then part C is a generic integration, which we don't do as often. So that one probably was the toughest part. So part A, K is represented by this composite function, f of g of x. So that's a chain rule. So you need to derive the outer function. So when I derived it, I kind of did my work in the opposite order. I actually did the derivative first. So I'm going to start there. Take the derivative of the f function, keep the inside the same, and then multiply by the derivative of what's inside. So this line right here where my cursor is, that's your chain rule generic derivative. You always work inside out. So you're going to go to your table and figure out g of 3, which ends up being 6. So then you're going to have f prime of 6 times g prime of 3, which is 5 times 2, which is 10. So that's your derivative, which represents your slope. To get the tangent line, you also need a point. So your x value is 3. The y value is going to come from putting 3 into this composite function. Again, work inside out. So you're going to figure out g of 3, which is 6. And then f of 6, which is 4, all of that coming from the table. And then you can see their work over here as far as what it's worth. Your slope, if you got the slope, they actually give 2 points for that, which I think is kind of generous. And then if you wrote the tangent line equation, you get a point. So this is how they wrote theirs. I'll show you mine just to compare. The only thing I didn't like about mine is when I took a picture of it, it got kind of light. So I might have to look a little closer to see my work. So here's my work. Here's my generic derivative with the chain rule. Then I went and put 3 in. Then I pulled the values from the table to evaluate, and I got my slope of 10. Then I found the y value by putting 3 into the composite function, and I left my answer in point slope form. The only thing they did on theirs is they got y by itself and added 4 at the end. Not needed as long as you have any form. You could even get it in slope intercept form, although I think that's unnecessary. Going back, part B is a generic quotient rule. I actually thought B was the easiest part of this question because they don't want anything extra. They don't want a tangent line. They just want you to derive it with a quotient rule and then put 1 in when you're done. So they went straight to putting the ones in, did the, here's their quotient rule, bottom times over the top, minus top times over the bottom squared. Make sure you read your table right. You don't want to miss a point because you accidentally plopped in the wrong number. So here's your f of 1, g prime of 1 is 8, minus g of 1 is 2, f prime of 1 is 3. You end up getting a numerator of negative 54, and then the denominator is negative 6 squared, which is 36. They would accept any answer that's equivalent to this. So you could write it, I think I wrote a variety. I had the negative 54, 36, which I give full credit for. I also reduced it to negative 6 fourths. I wrote it as negative 3 halves, or you could even write it as negative 1.5, anything that's equivalent. They gave 2 points for showing that you knew how to do the quotient rule generically, and then 1 point for the answer. My work, again, very similar. I was a little more generic to start. So here's my f times g prime minus g times f prime over f of x squared. Put my answers in, and you can see I have a whole bunch of variety of answers. So finally, part C. Part C, at first, I missed a step, and I'll show you, not necessarily, I just kind of stopped for a second. I know that when I integrate f double prime, I'm going to get f prime. What kind of made me pause for a second is there's also a little u sub in there, and they don't really write it that way. They just kind of do it. And so I want you to see mine because then I think it makes a little more sense. So here is my work. So the first thing I did, well, I stared at it for a little bit, to be honest. I wrote down my u sub adjustment. So u is the 2x because that's that inner function. Du is 2, so you have a 1/2 adjustment. So that's what this 1/2 is. They put it on their answer, but they give no explanation as to where it came from. So that's where it comes from. It's a u sub adjustment. When I integrate f double prime, I do get f prime. And then with my boundaries, it's always top minus bottom. So what I did is I left the 1/2 out front until the very end. We can do that with any constant adjustment. And then I put in my work of what happens when I put 3 in, I get f prime of 6, minus what happens when I put 2 in, or excuse me, when I put 1 in, I get f prime of 2. Went to the table, f prime of 6 was 5, f prime of 2 was -2, so you get 5 minus minus 2, which is 7, and then in the end multiply by the half. So let's go back to their rubric. They gave 2 points for integrating. My guess is if you showed that you integrated a double prime to get a prime and didn't understand that there was an adjustment, you probably would get 1 of those points because you showed what happens when you integrate, but you messed up the adjustment. You wouldn't be able to get the answer point unless you had that adjustment, because if not, you would end up with an answer of 7 instead of 7/2. They would accept any answer that's equivalent, so 7/2, 3.5 would be fine to get that final point. So I thought that was kind of a different question, a nice one to look at, because it was not as much of a word problem and a little more of just a generic problem. So that is your question explanation of the day. And again, hope you are all well. Talk to you soon.